Hello everyone. Uh, as promised, today afternoon we are going to introduce you with a new topic or new application, uh, Persona. So Persona is a we have seen many uh, monitoring systems. Uh, so some of our passive monitoring system, some of our base is NMP, like Acti, Nagios, Savix, and like things. So there are also active monitoring system. We in earlier session we discussed smoke pin. So likewise, the Persona is an active monitoring system. So why we need Persona? So actually, the classic monitoring system like uh, Cactinagios are good for monitoring uh, network devices. So network links uh, which are on or off. That is, they are good at detecting at downtime or fail situations. So, but they are not good or they are incapable of detecting uh, when there is a performance lag. So, in a time that somehow the connectivity is there, we can pin a site, we can pin a remote server, but we can't use it in a usable way. So, in that case, to detect such problems, we can make use of Persona. So, uh, normally, Persona is started within the research and education community, mainly by ESNet. So it was mainly intended for uh, discovering performance issues within research and education networks. But not limited to that, we can use it by now. Uh, even companies are using it for detection of network performance worldwide. So in this graph, you can see uh, uh, how the worldwide research and education uh, community is distributed and their connectivities. Any network actually consists of many uh, other networks. Network is a we call a network is a collection of network. So uh, like that, the research and education community network also consists of many type of heterogeneous that is different set of networks. So uh, they can be they are distributed globally and they can be uh, interconnected with different types of networks like um, regional networks, research and education backbone networks. Maybe they are going through uh, other commodity networks. So maybe going through these connections likewise. So finally, the what we need to is the end-to-end performance. Maybe from a Sri Lankan university staff need to access US or UK remote services and service and data without any performance lag, that with higher data rate and without any failure. So that is what expected to be the research and education network. So this depicts that in a research community, sources and the elements can be distributed worldwide. Maybe some data source, the monitoring source can be located in another part of world. So storage can be located in some other country, other region, and then finally the processing of data can happen in other location. So all these things happen in different locations, and but they all together should work as one. So to do that, those interconnectivity between among nodes or among resources should be seamless, and should be very reliable. So another reason is like sometimes some resources can't be accommodated by someone due to high cost, and so that some other country people are accessing some remote resources uh, with their collaborations. So that's a reason that this research and education network should have a good bandwidth uh, and uh, failure resistance. Also, another challenging thing that this research and education network faces is these uh, interconnected networks are owned by different organizations. Like it can be owned by a government organization or another academic and research institute or university, or can be internet service provider, commercial internet service provider, and such things. So different entities have different customers. They have different policies, and different funding models, and they have different hardware and capabilities, and they can have different bandwidth, and they within network they can have different configurations. So networks are different, and ownership is different. So uh, so maintaining uh, end-to-end connectivity, so reliable and high throughput end-to-end connectivity is very challenging. So if someone due to these variations and policies, so we can't we can only maintain our own network. Sometimes we also face in within our own network we can't sometimes handle our own issues. So how to handle other domains or other owners issues? So what we can only do is we can monitor those issues and report them using this kind of persona like tools. So we always know the word the bandwidth. So some people may not be familiar with throughput, mainly if not very technical people. So actually, what is bandwidth and throughput? So what are the differences? Uh, so through bandwidth is you know that we when your commercial home internet provider, you provide with the bandwidth 100 Mbps, like, or maybe your campus learn provide some 300 Mbps or likewise bandwidth. But uh, what is throughput? So uh, throughput is actually uh, actual data transfer rate. So compared with bandwidth, bandwidth is theoretical data rate. So when we provide 300 Mbps link, that means you can go maximum up to 300 Mbps. So normally, theoretically, you can't go beyond that. And uh, and it is also equal to we call it also channel capacity, the maximum channel capacity, and another word is maximum capacity. And when in below picture you can see uh, the difference between bandwidth and throughput. So it's bandwidth is like the uh, cars in a highway, tightly they are tightly compacted and go with some speed. So in that situation, uh, we can we can utilize the road with maximum efficiency. So in this case, we can fill up the road with 24 cars, and so 24 cars will pass some particular point on the road per second. So in contrast, throughput. So in actual situation, we can't go in that in a compactor, that uh, we can't touch other vehicles, and there should be some space between. So in actual situation, so so in that case, in this image, you see only 20 cars will pass some point per second. So that's the difference between bandwidth and throughput. Even though we provide you with some bandwidth, uh, uh, um, what you get is throughput. So throughput is actually limited by many factors. We will later discuss. We are discussing the factors that affect in that throughput, and what are the reasons that will reduce your throughput levels. So throughput limiting factors. One is network latency, and I also earlier said you the most affecting factors uh, will be a network latency and packet loss, and the other one is network congestion, and another one is enforced limitation, like when we provide you institute learn provide you institute with some link speed, maybe 100 Mbps. So that is a enforced limitation. Even you have 1 gig connection, uh, you only get 100 Mbps link. So likewise, uh, so other one is protocol overhead, and so protocol overhead happens in a transmission medium like interface, switch interface, route interface, so or cable. So we'll see again what are these one by one. So network latency means earlier in smoking you saw that RTT. So that's a metric of network. That's a measurement of network latency. Network latency means uh, how much it take the packet to go from some source to some destination. So this latency can be caused by the length of the path. That means if the packet coming from uh, some from Colombo to another place in Colombo, normally the latency will be less than 1 millisecond. So if it comes to somewhere around Candy or something, it comes a long way and passing through so many devices and fiber optic cables. So it will take around 6 milliseconds. So likewise, when we go beyond that worldwide, so it will take around 40, maybe 100, maybe 300 later milliseconds. So the latency is caused by the propagation delay. That is the how long it takes to pass the copper or fiber cable. And other one is the processing or routing or switching delay by active devices. And the packet loss. What is packet loss and errors is when we send a packet to from some destination, packet due to many reasons like congestion, hardware failure, software failures, the packet will be lost in the middle. So that is called a packet loss. Or maybe error packet will be received, so no use of error packet. So it's same like packet loss. The network congestion is in smoking. I showed the situation in network congestion. So where network congestion happen, uh, when there is uh, unexpected traffic passing through some link or some device, like if some link is capable of 100 mbps, so if we push more than like 90% of traffic, so there will be a congestion. So all the traffic used by the users will be slow and useless. So also another reason for network congestion is uh, uh, device incapability, that device resources, routers or switches have less buffers, uh, so they can't handle queues, and maybe less memory. So these less CPU performance, like those things can be a reason for network congestion. So and the enforced limitation, it is actually easy to understand. Even the link, physical link and the routing and router hardware are capable of going beyond some traffic level, but it is limited by deliberately limited by some ISP or network provider. So the other one is protocol overhead in a transmission medium like uh, uh, gigabit Ethernet or fast Ethernet. Uh, this happens. Uh, this happens due to the protocol the sort of due to the sort of operation of protocol, like when we designing a protocol, we can't just send the user user traffic, like when we see when we download some file, so file has some 12 say 10 MB size. So but to but protocol need actually mean protocol to pass those traffic from source to destination need some metadata, some other traffic to handle. Uh, so is sometimes like when we send a when we uh, send a snail mail, like we send in a letter envelope. So the actual content is inside inside the letter, but to send it we need another paper envelope. So likewise, so this is called overhead. So overhead can happen in any layer, like in Ethernet layer 2, there's frame overhead. And so like in IP layer, there's a layer 3 overhead, like layer IP header and trailer. So likewise, in layer 2, frame overhead can be up to 24 bytes. So it is actually sum of preamble and start frame delimiter. So preamble and preamble is actually used for synchronization of uh, devices at two ends. So to synchronize the communication, bit communication, so at source and destination, preamble is used. So start frame delimiter marks the beginning of a frame. So and also like in early example, we discussed that vehicles can't uh, vehicles can't run uh, in connection with others, that is in touch with others. There need to be some space. So likewise, for the frames also need some gap. So we call it interframe gap. It has 12 bytes. So if you use VLANs in our networks, there will be another 4 bytes added. So altogether maximum there will be frame overhead of 24 bytes in layer 2. So we'll next go to some sort of calculation, how this frame overhead affect the throughput level when it comes to some uh, uh, interface level. So uh, throughput is here you can see the equation. So throughput is uh, equal to this equation, frame size divided by frame size plus frame overhead, and all multiplied by switch port bitrate. So think you have a gigabit Ethernet network that it is theoretically supports 1,000 megabits per second. So but in actual case, we can't use that much of traffic. So according to this equation, so think we are using the standard frame size in layer 2 is 1518 bytes. So it has as we said, it has any layer 2 frame has at maximum has 24 bytes of overhead. So with this equation, you will get 984.43 something MBPS. So as you can see, due to this protocol overhead, we can't actually get the theoretical or actual channel bitrate. We can't get it, so it will be something something like reduce, something lower than that. So the TCP problem, that TCP has some problem with some latency, network latency and packet loss, unlike UDP. So because TCP is connection oriented, and it has flow control, and if some packet drop, it has to retransmit those packets, and uh, so that the actual throughput will be reduced due to these reasons. So this Mathi's equation, this is some equation to show you how these latency, round trip time, and the packet loss will affect the TCP throughput, right? Uh, in this equation, MSS, maximum segment size, that's and we can also say it, the packet size. When the packet size, so MSS is increased, throughput will be increased, right? But there's also some limitation. Maximum MSS can't be higher than some level, like MSS the maximum MTU, maximum transfer unit cannot be in layer 3, cannot be higher than 64 kilobytes, likewise. So and the RTT. So RTT and packet loss are inversely affecting this throughput. So as you can see, when RTT is incremented, throughput will be reduced according to the equation. And also when the P is increased, throughput will be reduced, but the RTT is more effective on throughput, negatively effect on throughput more than packet loss, because you can see packet it is square root of packet loss in the equation. So according to this equation, the maximum throughput you can achieve is less than what you get from this equation. So in practice, it will be less than what you get from this equation. So this is another table that shows how TCP throughput is affected by network latency and packet loss. So in left side, we go through several round trip latency milliseconds, and with that latency and no packet loss, you can have this TCP throughput. So without that means with 0 millisecond latency, the nearly 0 millisecond, and no packet loss, you can have 93.5 Mbps. So but with that latency, with only 2% of packet loss, you can have 3.72 Mbps. That's very low than this one. So see how much this packet loss is affected on this bandwidth. So likewise, in this case, when we increase latency from 0 millisecond to 30 millisecond, TCP throughput will be drastically reduced to 16.2. Likewise, you can see the results up to 90 milliseconds. So this is another graphical show of how how latency and packet loss affect on the throughput, and also this show about different networks, different domains, or different levels of network in the same time. So imagine in the x-axis you can see the round trip time, and in y-axis is throughput. So when the latency increases, so with some small packet loss like 0.0046 small packet loss, the throughput will be reduced drastically up to around 12 milliseconds, and beyond that slightly throughput will be reduced. So we can also see this in another aspect, like as I said, we can see different types of network in this graph. So in normally within LAN, local LAN, latency is not much higher, even though that there may be packet losses even due to some reasons. Normally there are very less packet loss within the LAN. So within the LAN, latency will be very low, like less than 1 millisecond. You can check also within your network when you pin your own router and things, it will take less than 1 millisecond. So in that case, you can achieve up to 9,000, up to almost 10 Gbps speed within your LAN. So when it comes to metro or remote metro area, like in larger metro area, so it will take the latency will be increased by some millisecond, maybe 2 or 3 milliseconds. In that case, we can experience around 5,000 throughput. So we can, from this graph we can imagine that in metro area we can go up to 5,000 throughput with this specific packet loss. And next comes the regional, that is think some regional, like between two countries, like, so it takes around it takes a bit more than 10 or 12 milliseconds. So in that region, throughput will be reduced to up nearly around or less than 1000 Mbps. Even you have the 10 gig network infrastructure, maybe 40 gig, but you due to this latency you can't go beyond this around 1000 Mbps in these regional networks. So in the same way, the continental and international links, so throughput will be reduced with the latency. And you can see this purple line. So with no loss, if there's no loss, sometimes this may be theoretical, nearly theoretical. So with no loss, you can have this much of traffic, up to international level. Even you can reach the other remote uh, area, another part in the world with around 9,000 Mbps speed with no loss. But normally that is not the actual thing happen. There will be some amount of packet loss. Uh, so that's the reason. So where these issues can happen, uh, normally when we access remote networks, we pass through several networks, several types of networks. Maybe in case of you pass to learn network, you pass to our service provider network, then uh, provide to another level of uh, internet service provider, or sometimes we also have some uh, academic networks, academic direct connections, backbones. So in that case, you have to pass through that academic network. So likewise, you have to pass through many types of networks. So the faults can be anywhere, like in this picture. It can be within your network, it can be in destination network, it can be a fault in your router, your switch, or destination router switch, likewise. So due to these reasons, throughput you expect will not have throughput you expect is will not have. So so issues can happen in many locations. Uh, you can't actually monitor these things. You only can feel these things, and you can maybe you can report by extended troubleshooting. You can find the region region that that slowness happens, so you can report to that particular network owners about this. And soft failures plus hard failures. So we normally know about hard failures. So classical monitoring systems know about hard failures. So they know about link down, like fiber cut, or routed down due to power failure, and hardware. Some hardware maybe cease to function, maybe crash, that is crashing, and also uh, many like these things. So these things can be easily detected by these classical monitoring systems. So what about soft failures? So the soft failure situations, only you can feel actually you know that basic connectivity is okay, uh, but network is slow. When you stream something, or when you access in some site or services, you feel more slowness than ever. but, but you troubleshoot, you ping it, it works, but you don't know why this happens. So that is a soft failure. And so in this case, these soft failures, you can't actually you don't even feel. Sometimes maybe there is a bandwidth lag, but when you browse, you don't feel it. You when you browse a normal web page, you can't feel this, but when you download something, you feel this. So what is persona? Persona is the in definition we can say it is a collection of software uh, or collection of tools for performing and sharing end-to-end network measurements. So this persona works in a federated environment. Federated means the persona nodes are collectively operated. That is, there are persona nodes worldwide. So all network measurements always run between these nodes. So that we can detect uh, any path issues and performance issues between these nodes. And this package collection of tools, maybe existing tools, and to perform these network measurements. We will see later what are these tools. There are around 10 or 12, 10 or something tools. And as we discussed, this is dedicated for actually detecting soft failures. So soft failures are hard to detect, and it goes undetected usually. So Persona is made for this. And the other advantage is this is deployed around all around the world in academic, mostly in academic networks, mostly in academic institute and operators like NRENs and other service providers like this, and laboratories and other science institutes. This is deployed. By now, it is said around 2,000 nodes are there in the world, around 2,000. These all are also registered nodes. There is a registration process, or that is automatic node registration process. So these are all registered. There may be also another nodes that are unregistered, maybe used within your own networks to measure performance within your network. So such nodes may be existing. And uh, this persona schedules the network measurement test. So normally this persona is an active measurement tool, so we have to run measurement test. So this is not passively monitoring anything. So we had to run, we have to send some traffic, send to measure to get the measurements. So these should be scheduled because there are many types of tests, that is throughput test, latency test, or some other DNS test, or uh, many different types of tests are run. So these need to be scheduled, otherwise there will be conflicts. So there's a dedicated schedule. We'll see later within Persona to schedule the measurement test. And this also archive that store the test results. That is, test results are very important because using these test data, we can create graphs and we can visualize data over the time. So we can detect what are the problems, what happened yesterday, what is happening today, right? We can see those things. And to visualize these results, there are tools like we'll see later. There's a called a mad dash, like dashboard, to visualize these archive data to graphs. Actually, Persona was initiated by effort by ESNet and Gene2, that is European network, and Internet 2 is American network, and RNP Brazil. So this is initial effort and by these organizations. So now this is also supported by other institute and universities. And measured metrics. So we can using this persona, we can measure many metrics. Metrics like throughput, one-way latency, round trip time, so packet loss, packet duplication, jitter, and several metrics can be measured using this tool. We earlier discussed about throughput. So throughput can be measured, and one-way latency. Normally, what we saw earlier is round trip time. That is two-way latency. That is uh, outgoing and incoming. Both two latency will be measured. In one-way latency, only from some particular source to destination will be measured. So also round trip time will be measured, and packet loss can be measured, and packet duplication. The packet duplication is happens when packet duplication means the same packet is sent twice by some error. That is duplicate can be duplicated by many reasons, like uh, like when we configuring aggregatedly, that is either channels, it can happen like in SD-WAN, it can happen the packet duplication, and in port mirroring, packet duplication happen. So in such cases, this packet duplication happens. So the other one is jitter. Jitter is the variations in arrival time of packet between two endpoints. So see, think we send the packet from A to B. It takes around 10 milliseconds. When we send again, it takes around 2 milliseconds. So there's a difference between arrival time. So that is the jitter. So this is the architecture for Persona. So this shows the components and how they interact with each other. This has the tools. This shows the tools, and this also shows the scheduler. Scheduler is the one who executes the task, or who executes the measurement task. So it uses below the down tools around like hyperf3, hyperf being like trace path, trace route. Those tools are executed from the scheduler to measure the measurements or metrics. And this also has archiving component for like SMAN database. SMAN is a time series database for archiving time time related data. And this also have some component called psconfig. uh, psconfig is used for configuring the task. Like we can, it is actually uh, template framework. That is, we can save, we can configure a measurement task, uh, what are the, what to be monitored, what will be the source destination, so when to execute these things. So those will be saved in JSON files, right? JSON, some of you may not know the JSON. So in JSON formatted file, we can save those things. These are called templates. So using this psconfig module, we can execute measurement task. So there are also visualization components like Mad Dash. Also there are graph module for creating graphs. So also there's a trace route weaver, and there's also web psconfig web admin for configuring the psconfig. So there's a toolkit UI to actually uh, monitor the and configure these measurement tasks, and view the measurement results. So there's also another discovery component, that is lookup service registration. There's a website that we can the website directory for locating and searching these worldwide persona nodes. So uh, the task of this lookup service registration component is to register with this directory. This happens actually when we have, when we assign a real IP, that is public IP, to your persona node. It will normally automatically register with the this directory. So these are the persona tools. Uh, One is WAN. That is tool is used for one-way latency, measuring one-way latency. That is only one direction, latency of one direction will be measured. So other one is TWAMP. That is, this tool is used to uh, measure measure two-way latency, and also it can measure the packet loss. So it is like a pin tool. The IPERF 3 and IPERF 2, these are two versions of the same tool, and this is used for throughput testing. That is how much maximum uh, bandwidth or maximum traffic can be achieved in a provided bandwidth. So the IPERF is used for throughput testing. And NUT TCP, another throughput testing tool. And trace route, you know, trace route is used for locating the path of traffic. That is, when we send traffic from one A location to B location, there will be many routers and many nodes in between. So we all need to trace what are these nodes and what will be the path. So trace route is used for that, and trace path is similar to trace route, um, but it also measure the path MTU, that is maximum transfer unit. So it has that capability. And Paris trace route is also like the previous two tools, but it helps to detect uh, the presence of load balancers when there are multiple paths, like when we go hop by hop, that's one. When we travel, when a packet travel by A to B, there may be intermediate hosts, but in the middle may be path, there may be two paths or another three paths. So in that case, trace route can't do it very well. uh, uh, in such case, Paris trace route can uh, correctly identify those multiple paths and give the results. And the other one is ping. We all know the ping basic tool. So classic tool. So it can be used to determine the reachability and the device availability and round trip time. Also, we can see the packet loss from that tool by sending actually to measure packet loss. We have to send so many packets, pin packets, to measure the packet loss. We talk about scheduling earlier. Uh, Scheduling is scheduling. We need to schedule tasks. Actually, we run different tasks. We run different tests, throughput test, pin test, or two-way latency test, or other kind of test that we saw earlier. So these tests uh, can't be conflicted, so that these should be somehow scheduled. Like consider throughput test. uh, when we send throughput test to destination at once, or they are overlap, so the results will be inaccurate. So in that case, we need to schedule those things. We need to schedule, like first throughput test is run, next another test run, next another throughput test run. Likewise, we have to schedule this. For that purpose, there's a scheduler inbuilt for uh, in Persona. Also, this scheduler execute the tools to, and also it gathers the and gathers the results, and it send these results for archive. So to say those results are sent to archive. That means we call it measurement archive or measurement database. So we can later those data, we can use those data to create graphs using Mad Dash tool. Archive measurement results. We talk about SMAN, that is time series database, uh, is used for archiving the measurement results in Persona. And this tool have two ways to set up that. In two configurations, this database archive to archive this archive can be set up. uh, the first one is actually the default way. When we there are several installation of Persona. There's a package called Persona Toolkit. So when we install Toolkit, uh, the measurement archive, the SMAN component comes by default. So we uh, we don't need to do any additional configurations. So measurement archive will be within the same host as the measurement host, that is the persona node, and the measurement results will be automatically uh, stored in the same host, uh, stored in the measurement database. The other way of storing this measurement results in a central server, that in a situation that say we manage multiple persona nodes. We need multiple persona nodes when we think when we have remote branches. Our university has a branch in Colombo, another branch in Anuradhapura or somewhere. Like it's a remote site, so we need always to uh, uh, measure our bandwidth between those two locations. So we have uh, persona node at both locations. In that case, there can be multiple persona node for all locations. In that case, you need to. It's much better. Is the recommended ways is to have a central server for saving all measurement results. So it is not recommended, and it is not actually useful to have measurement data in each database or each persona node. So uh, having all the measurement results in a single central server is very useful, because uh, it is it can be easily visualized. That is, uh, we can see those measurement results in graph uh, in a single web UI. Otherwise, we'll have to go through we have to go to every node web UI to see the results. So that is some cumbersome, and having a single measurement archive and single single dashboard is very useful. This needs actually additional some configuration that is not actually a trivial task, not hard one. So this can be easily set up. So in lab setup, we have tutorials for both of these setups. First, we will try uh, the first setup one, that is we set up a single persona node, and the measurement archive archive will be in the same server, and the mad dash, that is the visualizer, that is the web UI, uh, will be in the same server. uh, in the second setup, as discussed, as explained here, there will be a central archive server, and there will be two measurement nodes, and two measurement nodes will send the archive, that is test results, to the single storage, that single measurement archive, and the measurement that's visualizer, that's mad dash, will be in the central archive as well. So we'll discuss these two setups in our lab later. Configuration. So normally we can execute the measurement task through the web UI. There's a persona web UI. We can add measurement tasks there and run it, but it is actually not scalable. That is, when we have, like in previous case, when we have multiple persona nodes, we have to go to one by one and execute measurement tasks. So that is not practical. So the best thing is to use psconfig template framework. That is, uh, these measurements can be configured in this psconfig template framework in JSON formatted files. So these these templates is read by the there are two agents like scheduler agents and mad dash agents. Those agents read those templates and execute the task. So uh, the psconfig template framework is used in such environment. So it is very useful and the recommended way of using. Also, psconfig uh, yeah, as we discussed, schedule the task at multiple nodes, and it help me visualize the components to display results from multiple nodes in a single dashboard. So psconfig has two agents. Uh, One is psconfig schedule agent, other is psconfig mad dash agent. So schedule agent is normally run on the persona node, that is measurement host. We call it also measurement host. And the psconfig mad dash agent, that is agent used for the mad dash visualizer or mad dash web UI is run in the mad dash server, or may the mad dash server may be the it is the same as the measurement archive server. Normally mad dash and measurement archive, that is SMAN, run together in the same server. So scheduler, psconfig scheduler agent, its job is to read the configuration template JSON files and send those read and send those tasks to scheduler for execution. And the mad dash agent is the duty of mad dash agent is to read the configuration template and to help visualize or show the graph and results from the mad dash dashboard. So this is about how the visualization of measurement data happens in PF persona. Uh, Normally, mad dash is used to visualize this measurement result. Uh, so mad dash access the measurement archive, and using those archive data, mad dash create graphs and create some dashboard like below, like in a grid mode. So this the specialty in mad dash is actually um, it can visualize, it can display measurement results in two-dimensional way. We have several we have 10, like in this case it has uh, 15 measurement nodes. So in these 15 measurement nodes, there can be there are many combinations. So there can be many connections, right? It can be equal to the 15 square. The number can be equal to the 15 square. There's some equation for that, and so if there are n number of nodes, it can be it is somewhat equal to the n square, and somewhat n square less some amount nodes. So in this case, there can be uh, uh, these nodes can be connected in a mesh way. That's the maximum number of connectivity connections that can have. So each one in a mesh connection, each node can be connected to other each node. So maybe not directly, but somehow indirectly, these each of node can be connected to another node. So only situation that cannot happen is the same node cannot be connected to same the itself, right? In this white boxes. So in that case, it is not happening. So same node can't connect to itself. So in the other cases, the like node 2 can connect to node 1, likewise up to node 5, node 15. So in this type of setup or connectivity, so we need to, it is very useful to have this type of dashboard, or like a grid-like dashboard. So it is supported by MADDash. So upon clicking these boxes, we can see the results, like hovering on these boxes. If you think if this is a packet loss uh, packet loss visualization, packet loss graph. Uh, so when we hover these boxes, it will show this. If this is green, it will show something 0% packet loss. Like if we click on yellow, it will be something 2%. Likewise, it will visualize the results. So we earlier discussed about the worldwide persona nodes. Uh, there are around 2000 persona nodes all around the world. The registered node. Also, you can see here if the image is clear. These are so amount around 2000 or something. So if you access this web URL, you can search for a particular persona node that is a registered node all around the world. You can search in this box. So you can browse from these services. The left side shows what are the services running on those nodes. So you can filter using that browsing directory as well. So this website shows what is each uh, measurement node services running, and what are the other details, what are the other administrators, and what are the host capabilities are there. So by seeing by going to that particular node, uh, you can get details, and you can have a measurement test to any of node. So these nodes are open for testing. So you can schedule a test either by using your persona web user interface, or either by psconfig template framework. You can schedule a task which any of these node. Okay, how to deploy the persona? The recommended ways to deploy it is in Science DMC. Science DMC is Science Demilitarized Zones. DMC means Demilitarized Zone. So in that zone, uh, actually there's no traffic filtering virtually, but there's no traffic filtering. There's no traffic throttling. So Normally, science DMC in your network means some network connected to your border router, or actually it is not behind the firewall. So there's no firewall between DMC, and normally there's no filtering between DMC and the science DMC and the outside network. The reason not to filter is actually for the high performance, and because firewall creates some throughput. Firewall causes some throughput issues. So that's why we have this. We would like to have this perp zone in this DMC zone. So other scientific applications shared by other global collaborators will be also hosted within this science DMC. If you have multiple sites, remote branches, you can have Persona nodes. Persona node within those branches also. This shows such situation. So if you want to test a measurement test between sites, or from a site to the outside, or maybe from a site to the border router, you can conduct a measurement test from this Persona node to Persona node located in DMC zone. So in that case, you have to remove some particular firewall rules, or you have to allow some ports for that particular outside that Persona in DMC zone, so that you can run a throughput to any test between these nodes. So in this setup, you can measure within your own LAN. On-demand testing. Imagine Persona is always used for regular testing. That is, it is normally intended for scheduled testing. So test can be run on scheduled manner, maybe 12 p.m. night throughput test, or pin can be scheduled, or latency test can be scheduled 6 times a day in regular basis. But when you face an issue on your links, you can also have a on-demand test. That is, you can go to that, or you can arrange a person from another location, maybe in this case remote site. You can have a test from there to Persona node in DMC zone. So maybe this remote site does not have a Persona, so that's why this person is there with his laptop. For this on-demand testing, actually you have to install there is a package for Persona. There are different measurement options for installation options for Persona. There's a Docker option, that is Docker means container based installation. Docker option for installation of this Persona. You can use this Docker option to install to Persona in your computer or laptop. Then you can measure on-demand test from this particular site to this Persona node to troubleshoot any issues. So if your network admin and you are using a persona, you need to develop a test plan. So normally you can what you need to test is throughput, packet loss, availability, or latency like measurements. So think you want to measure throughput. So you want to measure throughput in some situation like you have a research collaborator in another country. So if there is some performance issues, or you want to see if you to run some particular application or to have some data transfer, you want to test the throughput between two locations. So you can locate that persona node. If there's a persona node in that location or in that collaborator site, you can have a throughput test between them. And other use cases, normally if you are accessing uh, some services occasionally, or use services more often uh, than other services, so you can find a persona node near, very near to, or actually it is very useful if you can find a location uh, persona node located at the site. You can run a test between that site, that node and your node. Also, it is very useful as discussed to measure uh, test, regular test, to ensure the throughput uh, between your own site, maybe your own remote branches. When you conduct a throughput test, normally it may be very less times. We can't say this much time, 4 times or 5 times. You can decide it, uh, but it will be very less times than other tests like packet loss or pin test. So you can schedule normally throughput test for minimum time like 20 seconds or 15, 10 seconds, because if you run a throughput test, the all the bandwidth of your network, backbone network, will be consumed. So the users can't access the internet and other services. So you don't do run for longer than 20 or something seconds. And you also should think that to consider these tests overnight or off-peak times, like not in daytime. Maybe if there's a daytime issue, you can run it at lunchtime or on demand, not in a schedule basis. So, but you can schedule it in nighttime or peak time. For packet loss, availability, and latency test, those are not much bandwidth consuming uh, test. So you can run those things between your collaborators, research or academic collaborators sites, and your between sites of your services, and between your own remote branches. Uh, y- uh, these type of test actually can be scheduled in a regular interval, because they are not consuming, or they are not uh, troubling the user bandwidth. So users will be able to access the internet while running these tests. So that's all about the presentation. Uh, if you anything, any query, I will answer. I hope you got something about persona and uh, where it is used, why it is used, uh, how it is useful, I think. So next session we have to now it's 3 o'clock. Up to 4 we can quickly download, if you have download the uh, persona node in our website, uh, uh, you can download in a virtual mount in a virtual box and start it and do some small configuration like IP configurations, and whether it runs test whether it runs okay and you can access the persona UI. So that is what you have to do today. uh, Tomorrow in the morning session we are going to go through the its web interface and graphs, and uh, we conduct we conduct and schedule some tests through the web interface, and next we can also try out like measurement archives and mad dash for displaying measurement archives results. So we can try out if you are successful today. Anything about presentation? Maybe you know everything. That's why I'm not asking. You can download the persona node here if you haven't downloaded yet. It's actually the toolkit version. Uh, that is persona is uh, bundled with the operating system, and so we don't have to install persona there. Normally, installation for Persona installation, it is recommended to have a minimum of 2 cores and 4 GB RAM, and also it is recommended to have a dedicated server, that is not any on any virtual machines or containers, to experience the maximum results. So it's much better if you can have 4 GB memory of your VM. For now, we are using VM for this. You can also see that if you deploy in your campus or things, uh, hope to test 10G part, you need to have 2.8 gigahertz or higher clock rate, and such there are some recommendations. So here, as I said, there is container-based deployment, that is Docker deployment. Also, you can host it in low-cost node, low-profile hardware and cheap hardware. If you do that, if you deploy it in low-profile hardware, you will have to store archive in another server, measurement archive in another server, and also the MAC dash in that another server. Persona have different options, package options, installation options. As you can see, there are 5 options there: Persona Tools, Persona Test Point, Persona Core, uh, Persona Toolkit, Persona Central Management. So, don't know that you can. This graphic shows how they are, how the packages are related. The minimum package, the smallest package you can have is Persona Tools. So it has all the basic tools required, but it does not have any scheduler. So you can't schedule any tasks by installing this package. Also, you can't register this node because it lack of this ls registration component, and also it does not have this scheduler agent, so it can't use psconfig configuration template. So this is the minimum package. So you can install using package management, like in Ubuntu apt-get persona tools, apt-get install persona tools likewise. And the package beyond that is Persona Test Point. It can be registered into that global directory, and it has a scheduler, so you can schedule tasks, and it also come with psconfig scheduler agent, so it can read the configuration template and execute test. The other the up level package is Persona Core. So it has the SMAN. SMAN means the data archive database. So the Persona Core if you install Persona Core, you can archive archive data. And the today actually we are in this workshop, we are going to install Persona toolkit, the full version. So it has also all the GUIs, that is web interface, other system and security features, and all together with the Persona Core. And there's another separate package called Persona Central Management. Actually, this package is not used for measurement. This package is used for measurement archive and uh, visualizing the results using MANDASH. So this package is used for that, not for any executive measurement task. So in our lab, we will use this Persona toolkit and Persona Central Management also. There's also documentation for how to install Cisco Toolkit ISO. That is what we are installing today. And there's also package management bundle and Debian Ubuntu installation packages and Docker installation. Okay, this is the Persona setup. So as you can see, the Persona is actually we are not going to run Persona in connected to any of your the current lab setup. So it is not a part of the lab setup. So this Persona node uh, you should install uh, in isolation with your with this lab setup. So if when you download and uh, mount this virtual machine, Persona virtual machine, you should set up the network adapter in bridge mode. Otherwise, this will not work properly. So I have the Persona uh, VirtualBox file with me. I hope you have downloaded this one. So I'm going to actually I now that setup I haven't shown that how to load this Persona file into the VirtualBox and how to do basic initial configurations. Uh, so I'm now going to show you how to load this Persona file. So this is the downloaded file. So first I'm going to create a new virtual machine. So I'm going to give a name Persona 2. So machine folder will be the default location, and we have to choose remember to choose Linux. So and there's also we have to choose the which Linux variations. Actually, this is CentOS, so CentOS is not listed here. So Red Hat is the commercial uh, version of CentOS, so we can choose Red Hat here. So Red Hat 64-bit version you have to choose, right? Continue. Then, as I said, it is much better to have uh, 4 GB RAM for this setup. I select 4096 megabytes. Then create a virtual hard disk now. Hard disk file type, go ahead. And storage on a physical hard drive, dynamically allocated, not fixed size. Then we give, I recommend you to give around at least 50 GB for this setup. So select create. So for Persona, VM is created. So we have to now mount. We have to mount the sorry, I mess up everything. It is important, no? Uh, this is not obvious. So don't have to create. You want to create if you are installing from iOS image. Sorry for this. You have to import this appliance. Hello. Sorry. Somehow I think I was not audible for you for some time. I don't know how much you miss. I think I will. Uh, I will demonstrate how to import the download persona OBA file. So I have. Yeah, I will. So okay. I think you can now see me and hear me. And this is the OBA file I have downloaded. So I'm opening this virtual box. So I have to import this. Sorry, my virtual box crashed actually. So I have to import this OVA file. So I'm selecting the OVA file using import persona OVA. So once selected, continue. Then by default, the RAM has been set up for 2 GB, that is 2048 megabytes. So if you have more RAMs, you can edit this. You can go for 4 GB. That is the amount of recommended minimum RAM for this setup, and number of cores is 2. Others are okay. Keep them as they are. Also, you have to select generate new MAC addresses for all network adapters. So there won't be any conflicts of MACs. Then click on import. So now I'm finished with importing the persona OVA file, and once finished, uh, I'll go through the settings again. Yeah, you have to make sure you are connected to bridge adapter, not NAT or anything. Also, you have to ensure that promiscuous mode allow all, and other important settings like RAM, processor, and are they are as expected. So once you verify them, you click start. As I said, you are not going to connect uh, this persona to the existing lab environment. So you are running this setup in parallel with others, not inside lab setup. So you are using a bridge adapter. So the persona should get whatever the IP address like you have in your laptop or desktop computer, that is the host computer. So same IP, same IP from that particular range should be assigned to the persona node also. Now, yeah, the persona is starting. That is actually the toolkit is bundled with the CentOS operating system. So I think you are going with me. If not, please chat me or let me know. So sorry for the previous things. So booting is finished. Now yes. So once you have to first log in with the root user. The root user username root user password is given here. That is the NMM Lab 2022. There's another user called user. So that also has the same password. So you don't have to go through any installation steps. Uh, so you have to actually start from here. Uh, once you uh, once you import the OVA file from the VirtualBox, you have to start from here. So previous are not relevant to this. Sorry for that confusing you. Once login, you have to carefully choose the steps and follow the steps. So you ask to enter website persona website administrator uh, account. So uh, there's a persona website web UI. So I am entering here admin, and it asks for password. You can enter any username password that you prefer. I am entering the same root password here. So now you are asked to disable uh, uh, root user access. That is access from SSH, and also asked to create a new super user account. Yes, click. So next, you are asked to enter the user. Uh, you have to specify a user account here. Uh, to enable the super mode. That is, if you have an existing user account, you can you can add that user to uh, you can add that user as a super user. So you ask to enter account. Actually, this in this installation, this OS, there's a account called user, right? Uh, so I am entering that account here, right? Now the root SSH is disabled. So the existing session will be there, but once you log out, you can't SSH to this host, but you can access from actually this virtual host, but you can't remotely connect to this machine from root user. Now let's see. Now I'm going to log out from this account, root account here. Right now, I am trying to access this server using the user account. the name of the account is also the user. So I am giving the password that I set earlier. So now I'll log in with the user account. As you can see, there was no error, so that means this is the super user. Otherwise, when you execute this sudo command, you will be given error that you are not a super user, and this will be reported like this. Okay. Once you do that, you have to uh, do IP configuration. Hello. Sorry, I was disconnected for some time. Uh, Right. So I had also some problems with receiving the IP, right, from DHCP. So, but now after resolving the connection, and I have received received an IP address. So actually, this is an DHCP IP. So we recommend to have a static IP from the same range. Also, please use Ethernet connection as possible. Don't use Wi-Fi connections for the bridge adapter. So you can test the connectivity from bringing the Google DNS outside, and right. As in this window, you can set a static IP here. You had to add the IP ADDR field and gateway and DNS server, DNS1, 2. If you use one DNS server, only you can specify DNS1 only. And also you have to specify a prefix. Normally it is 24. And also you have to set boot protocol to none. By default it is DHCP. Then to apply these settings, you had to restart the network service using this command. Then actually it is a good thing, good practice to set a host name. So you can set a fully qualified domain name or normal domain name. So you can set like persona dot your institute domain or whatever thing. If you are in your institute, if you are in your home, you will set just a normal host name persona or PS likewise. Whatever the host name, it will be okay whether you specify it with domain name or without domain name. But if you are if you are setting up a production persona, it is actually very recommended to have a domain name as well. So this goes persona dot whatever the your domain institute ACLK like. If this is a public IP or public netted IP, you can set a DNS name. So in lab setup, we can't normally do that. We can't assign a DNS record for this IP. So you can access the persona website by using the HTTPS IP address when you enter IP address, it will just automatically redirect you to toolkit page. If your VM don't have a public IP, so I think most of you don't have a public IP assigned because most of you are connecting from uh, netted IP, that is local IP, or from your home. So you don't have access to public or real IP. So in that case, there will be error like this. Error means something warning like this. All detected addresses are private and private addresses are disabled. So likewise, to remove this error, you have to access this file. etc persona toolkit web admin. So with sudo command. Sudo. So in that case, if you are shown that particular error, you have to set this value, that allow internal address attribute value to 1. So in my case, I don't need to do that because I have a real IP. So my IP is 192.248.4.79. Let's see whether it works. Yes, it works. So when I just enter the IP of the VM, that is Verbsona installation, you should see you should see the toolkit page. Okay. I think Manoj has got the start page. That is, he has completed installation and loading the VM. So this is the image he has sent. In this, he is also shown this error. So you have to edit this webadmin.conf and set that allow local address like variable to 1 as I shown you, and yes, you can discover the page, right? You can see the down there the services running: SMN database, LS registration, OM tool, scheduler, psconfig, template framework, and TWAMP. So those services are running there. Also, right side you can see the health, CPU, load RAM, and like these things, hard disk variables. Also, you can see the host information, NTP sync. So make sure that your service NTP sync. If it is no, yes, I will show you how to try it. Yeah, how to try it to make it yes. And sometimes if you have a private IP address, sometimes you won't be globally registered. It will be no. So these two are some uh, the fields that you have to concern about: NTP sync and globally registered. And once you come to this page, then you can log in. There will be some warning shown because there's no certificate installed, right? So we have to accept the risk and continue. So we set up earlier at the initial boot uh, persona user account. So I will log in with that. Right? To actually to do any configuration, you have to log in with the admin or any user account. Once you log in, right, if you are shown NTP sync is no, go to configuration. Right, once you are logging, then you have to go to host tab. Then you have to click the select the closest server. But before that, I suggest you to enter this administrative information that is actually shown to others, so that others and the global registration service can detect this, identify this node. So you can enter organization name, some name. It's okay. Enter your own organization name and admin name, your name and email, city, country, state, province like Peradine is Kandy or Colombo or something. Zip code, latitude, longitude. You can also try to autofill some. If you and so manually entering is okay because autofill will not give the correct one because it will get the latitude longitude based on the IP address, so that's not accurate. So site name. Site name is like you have multiple sites, you can enter site name. Like you have Colombo site, Jaffna site, Radhpur site like. So you can enter the domain here. Right? Right. In this case, our learn domain is learn.ac.lk, and you can also the type your node role, right? As we learn, we are in range, so we are entering in range. So not you are not regional. Yes, you can enter science DMC. You are not the exchange point. You can enter test host likewise. Right? Then you can assign node access policy public or RNE. So RNE a better option. So public peer persona nodes can't be persona nodes can't access this, right? And right now no need to select any access for policy nodes or at any or select any communities. Once you do the configuration, you have to enter save. Then once you do that, you have to set the go to host configuration and set up things. So finally, make sure your NTP sync status is yes. If you are accessing from private IP address, sometimes global registration status will give no. Actually, in that case, your node will not be shown to other in that global directory. So, but sometimes it won't be a problem to run test for some tests. So actually today session time is exceeded by 24 minutes. Our premises are also being closed. So I think you can try out this with this. What you have to do is you have to finally get this toolkit initial page. So I think hopefully you will be able to do this by today. So tomorrow there will be some tomorrow will be the lab setup. So we will go through these contents about persona toolkit UI, web UI, and how to select a node from global directory and add the schedule test from the web UI. Then run some on on-demand testing, on-demand test like this, like trace out, trace path. Then we will go through some test results and yeah, we will go through the test results dashboard and we'll see what are those things, what are the graphs and how to read them. Once we do that, we have to actually go to set up archive, how to archive your measurement data with Esmond, and how to display, how to install and display those data with Mad Dash. So those, there are some actually some configurations, many configurations there. So it is much required to complete today's setup. Otherwise, this much of setup is unlikely to be finished in 2.5 hours. So thank you for attending today's session. So we are going to close today's session. So we'll meet tomorrow, and hope you will come tomorrow with Persona install and by completing today setup. So